Here are a couple of examples of the use of the quotient rule. So the quotient rule is used for things given as a quotient, a division. So you'll use, when you see a fraction, you can use the quotient rule, okay, unless it could be simplified first. So you get given this formula, which is very exciting news, and so you just need to substitute into it and apply it. This time it does matter what we use for u and v. So u must be the numerator and v the denominator. So for this example here, we have a fraction. So we're going to use the quotient rule, and we're going to have u on the top, okay, and v on the bottom. So let's look at u first of all. So u is just x squared. And when we differentiate that with respect to x, we get 2x. And v is 5 minus x. And when we differentiate that with respect to x, we get minus 1. Okay, so now we need to pop it into the formula. So we've got dy by dx is going to be v times du by dx. This time note it's a minus. The product rule has a plus, this has a minus. Minus, and then u, so x squared, times by dv by dx, which is minus 1, and that is over the v, so 5 minus x squared. Right, never, unless you're given a particular format to get to, never ever expand that denominator. Okay, you will need to expand and simplify the numerator if required to simplify, but never expand the denominator because a factorized version is a lovely simple version. Okay, so if the question just asks you to differentiate, then just stop there. If it requires you to simplify your answer, okay, then we would simplify it. And actually this one, I'd probably put the 2x at the front. Okay, so I'm going to expand the numerator. So I've got 10x minus 2x squared, and then take away negative, so add x squared. All over, I keep this bit in brackets. Okay, so the numerator can slightly simplify. All right, and then that would be easy to factorize if we wanted the numerator factorized. Okay, let's have a look at the second example. So again, the numerator is what we call u, and the denominator is what we call v. We know we're using the quotient rule because we have a fraction. Okay, let's focus on the numerator. So if u is equal to 2x plus 9, then we know that du by dx is 2. And if v is equal to 3x plus 7 all squared, for this you could either expand out or you can use the chain rule. So I'm going to use the chain rule but in my head. So I know that I'm going to multiply by the derivative of the bracket. So I'm going to have 3 times, and then I bring the power down, then I write my bracket, and then I reduce the power by 1. Okay, right, so now we can pop those into the formula. So sometimes this gets a little bit long, so we'll give it some space. So we've got dy by dx is going to be v times du by dx, so that's times 2, so I'm going to put that straight at the front, minus u times dv by dx. Okay, so I've got 2x plus 9 times 6, 3x plus 7. And that is all over v squared. So if v is originally 3x plus 7 squared, when I square that, it goes to the power of 4. And again, make sure you never expand that out in the denominator. Okay, so I am going to tidy up the numerator. So I could write 3x plus 7 squared minus, I'm going to bring the 6 to the front because it's a number on its own, and then I've got 2x plus 9, 3x plus 7. That's perfectly respectable. You could leave it at that. Okay, I'm going to do a little nifty trick for factorizing. So I can see that there's a 3x plus 7 here, and a 3x plus 7 there, and 2 goes into both terms. So I can do 2, 3x plus 7, and I'm left with, multiply it by 3x plus 7, and minus 3 times this. So minus 3 times 2x is 6x, and minus 3 times 9 is going to be minus 27. So let's just tidy up the second bracket. Three x take away 6x is going to be negative 3x, and 7 take away 27 is going to be negative 20. Okay, so you could take the minus out the front if you wanted to. There we go.